How do you make predictions using AI? We'll explain. Hello and welcome. I'm Oli and I'm here with world's most amazing co-host, Jati.
Hello, everyone. I'm Jati. Thrilled to be here. Today, we're going to demystify how AI takes text, turns it into numbers, and helps us make smart predictions. Let's jump right in.
Yeah, thank you. Well, actually, okay, to be fair, it's not the AI directly who makes the predictions, but the AI is needed to get the data that you need to make the predictions, because in most cases, we have lots of text describing a series of events, and you need to take that and put it in a form where a predictive model can actually be used.
Exactly. Think of AI as the prep chef. It chops all that messy language into neat, digestible numbers. Once that's done, your mathematical model can look for patterns and tell you what might happen next.
Thank you. So basically, how does that work? Well, there are different ways. First of all, AI can extract numbers that appear in the text and put them in the proper context, identify them as the observer they're used for. Also, AI can, from a description, extract the events that happen, then categorize them, and then add the numbers to the events. And also, AI can analyze text in various ways, for example, to detect tone and so on. What else can it detect, Siyanko?
Oh, quite a bit. AI can detect sentiment, so you know if people are happy or frustrated. It can extract key entities like names of products or companies. It can even figure out the relationships between events, like cause and effect. All that context feeds into stronger predictions.
Yes, and I'm thinking about numbers that AI can extract from text. For example, a tone, or like you can do things like that, right? Like what numbers you can extract that describe what the person is, for example, feeling.
Exactly. You can turn sentiment into a score, like on a scale from negative to positive. You could quantify urgency from language, or extract frequency, like how often something is mentioned. All these numbers help paint a picture that models can learn from.
Thank you. So then, once you have the numbers, you can apply a model. There are basically two very important class of models. One is if your events neatly fit into scenarios. So in every scenarios, you wonder, for example, what if A and B happens? How likely it is that also C and D are happening? So one important class of models to go use here is Bayesian models. Can you explain what Bayesian models are, Sayanko?
Of course, Bayesian models basically use probability to update what we believe. You start with a prior belief, like how likely something is, and as you see new events, A and B, you update those probabilities to predict how likely C and D are. It's all about refining your expectations as you get more info.
Thanks. And another class of models is time course models. If your events don't just group into scenarios, but you have a time for each event when it happens, then you can use time course models. What are examples for such models, Sayanko?
A great example is ARIMA, Autoregressive Integrated Moving Average, which looks at past values to predict future trends. You've also got LSTMs, long short term memory networks, that are great for learning patterns over time, like predicting stock prices or sales trends. Time series models thrive on that chronological data.
Yes, thank you, Sayanko. Of course, in this case, we're thinking more not about some value that we track continuously, we're thinking about events that happening. So in that case, you want to, for example, relate an event happening at one time, um, impacting the probability of another event happening later. Do you know some models that can handle that?
Absolutely. For event based sequences, you could use something like a Hawk's process. It's a model that says one event can increase the chance of another event happening soon after. It's great when you want to capture that ripple effect of events across time rather than just continuous values.
Great, thank you, Sienko. Also, other models?
Sure, you've also got neural networks for sequences, like transformer based models. They're great at spotting complex patterns between events over time. And for simpler cases, logistic regression can help predict whether an event will happen or not based on your extracted features. Different tools for different predictive jobs.
Yes, thank you. There's also Markov chain models you could use. Can you explain those?
Absolutely. Markov chains are all about what happens next based only on where you are now. So if you're in one state or event, the probability of the next event depends on that current state alone. They're simple, but powerful for sequences where each step depends on the last.
Awesome. Thank you, Sianku. Anything else you would like to add?
Just that when you're making predictions, always keep an eye on the real world context. Models help, but they're best when paired with human judgment. So experiment, iterate, and never forget the bigger picture.
Exactly, Sianku. Yes, always keep in mind, verify what your model says. So yes, thank you all for watching and hope you enjoyed it and learned something new. Please like, subscribe, please leave comments what you like, what you didn't like, and what we should talk about next. Thank you again and see you hopefully soon.
And I can't wait to dive into more fun topics with you all next time. Thanks for tuning in, and until then, keep exploring, stay curious, and take care.